warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Selamat siang dan salam sejahtera untuk kita sekalian. Sekaitan dengan pandemi COVID-19, UP Kampus Purwakarta secure secara daring atau secara online ya. Perkenankanlah saya mengucapkan selamat datang pada acara webinar ini. Yang saya hormati Bapak Wakil Direktur UP Kampus Purwakarta, Bapak-bapak dan ibu-ibu dosen UP Kampus Purwakarta, baik dari Prodi PSTI, Prodi Sistel, Prodi PGSD maupun Prodi PAUD yang dalam webinar siang hari ini hadir. Yang terhormat Bapak Ibu hadirin sekalian para peserta webinar yang berasal dari berbagai instansi ya, khususnya mahasiswa PSTI UP Kampus Purwakarta. Yang sangat saya hormati PhD, beliau adalah akademisi dari Rusia. What I really respect to the distinguished guest, Mr. Speaker Alexander FIlonenko, PhD. The program this afternoon was different even than usual, because at this afternoon, PSTI study program presented a guest speaker, Mr. Alexander FIlonenko, PhD. Hello, Mr. Speaker.
Yes, hello. Nice to see you and to hear you.
Nice to see you also, yeah. To enlighten us regarding research methodology, especially in the industrial sector, which is closely related to information system and technology, of course, with the theme Webinar Education Research on Industry After Academic. Your Excellency, Mr. Speaker, may I introduce you about our university. Indonesia University of Education of Purwakarta is part of main campus in Bandung. The main campus has about 36,000 student body. But in Purwakarta, we have about 1,500 students. The UPI of Purwakarta has 4 study programs, plus 1 program in progress preparation. First, primary teacher education program. The second, early childhood teacher education program. The third, information technology and system education program. The fourth, telecommunication system program. And the last, still in progress, but haven't opened yet, artificial intelligence and mechatronic program. So totally we have 1,500 students. For the information technology and system education program, its program emphasizes on the area of information system and information technology, as well as education, of course, because in this study program, we're preparing vocational teacher, especially in the information system and information technology teacher. I would like to highly appreciate you for coming and in giving webinar in UPI of Purwakarta. Come to this webinar also students from different university of Purwakarta campus, such as student of UPI, student from Unjani, UM East Java, psychology from Ciamis, Gunadarma from Jakarta, Stimik Akakom from Yogyakarta, Subang University, University of Diponegoro, and STA Jakarta. Of course, still cannot webinar. Have a nice seminar. When the pandemic stop, we really do hope that you, Mr. Speaker, Mr. Alexander, for coming to our country in Indonesia. Welcome, of course. Thank you for coming and giving seminar through website. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam.
wabarakatuh. Baik, terima kasih kepada Bapak Profesor Turmudi MSc PhD yang telah memberikan sambutan dalam acara webinar kali ini. Nah, selanjutnya apa Kak Anissa?
Nah, selanjutnya kita akan mulai nih webinar education ini. Nah, untuk webinar kali ini akan dimoderatori oleh Bapak Joko Haryono. Kepada Bapak Joko Haryono, kami persilahkan.
Terima kasih Mas Dimas dan Mbak Anissa. Good afternoon, webinar members. Today we will explore more deeply about research methodology. Before we start the webinar, maybe I will explain briefly about the presenter for this webinar. Mr. Alexander FIlonenko, Doctor of Philosophy. He is my lab mates or my university mates when I study in University of Ulsan, Korea, Republic of Korea. Now he was joined to the company in Russia and in Moscow because Moscow is his hometown. That's why he come back to his country and join the company. Why we invite Mr. FIlonenko, or actually I call him Sasa. Alexander is the name in Russia, famous name, and most of them call Alexander is Sasa. Sasa is very professional and is very strong in the hardware development. That's why when we are working together in my laboratory, my supervisor, he always give Sasa job for hardware, especially in IT development. So because he is very strong in hardware, almost us know him not only a researchers, but he is also very engineers. That's why this webinar will be very useful to know him, how he has used his knowledge in researchers and combine with his ability in engineers together and make them as the good collaboration. Okay, while we start, maybe you can also see the curriculum vitae of the Mr. Alexander. He got the degree in bachelor degree in Russia and in Mamo. Yes, and then continue his study in University of Ulsan for a Doctor of Philosophy. Before we start the presentation, I will give some why we are interested in research. Maybe we should know. Many people try to study something, but why they used to be a researchers? As I got when I study in University understand at least three. First, we should very joyfully with our works. I mean, researchers should hardworking and hard studying, and also maybe we need to be very takes our time for studying. That's why we should enjoy with this situation. The second, if we want to be a good researchers, we also need to have such as self explorations. I mean, as we know now, information is very crowdly. Many information we can get from internet or from other media, but all the information will be used if we use our knowledge, if we use our self exploration to combine them as the good information, and then we propose something to the knowledge or to the research. And the last, as a researchers, we also need to be a very curiosity, have curiosity, because if we don't have any curiosity, we will not deeply explore something, deeply asking something from the situation or information. That's why three things we should enjoy with our work. The second is we need to be uh, exploration in ourselves, and then the last is we need to be the man with much curiosity. This is the basic why we need to be researchers. And please welcome Mr. Alexander FIlonenko. Then you have such time to present about your experience in industry or in after academia. You have time 20 minutes for presentation, and we try to make discussion for 20 minutes later. Then we hope we can have many things. We can have many benefits from this webinar. Please talk, Sasa.
Okay, thank you for your kind introduction, Professor. Sorry, Turmudi. I'm sorry if I pronounce not correctly your name. And thank you, Joko, for your introduction of me. Actually, I've made a small mistake in my CV. I graduated from the University of Ulsan in 2018. I showed here it's 19. So let's start my presentation. I hope you can hear me well and you can see me as well. Can you see my screen, like research in the industry after academia? Can Joko maybe tell me?
Yes,
can you hear me well and you can see? Okay,
I can see
that's
well.
nice. That's nice. So let's start. I'll talk to about like my background and how I became a researcher. So my first degree, it was actually engineer's degree, not bachelor degree. In Russia, we have 5 years program to get an engineer's degree. And I was studying at Moscow State Technical University. The previous name was MAMI. It's Auto Mechanical Institute in Moscow. And I graduated in 2011. And I was doing mostly programming of industrial robots. I was studying programming and automatic control, and then I moved to South Korea, where I was pursuing PhD in electrical engineering. But actually, it was not exactly electrical engineering, but it was a combined thing between electrical engineering and computer science. Because our laboratory is Intelligent Systems Laboratory, where I and Dr. Joko graduated from. It was doing projects about mobile robots, about computer vision. So it is not actually electrical engineering, but a combination of everything. You can say even mechatronics, because we were programming microcontrollers and electric motors. So after spending so many years in academia, so I started my university life in 2006 and I graduated 2018, so 12 years in academia. I moved to industry and I found a job at Abi Production. It's a company which was started in the beginning of 1990s. Okay, I could hear myself. So that company works with computer vision for a long time and image processing. And, they try to scan documents and extract text from the documents. They started with that. It's called, the program. Their first program was called Abi Scanner. So I joined that company as a senior software engineer at R&D department, but actually I was doing a bit of research work too. But that research work is different from the thing what I was doing in academia. I'll tell you like how it is different. Then I moved to Soft Telematics company. It was my second company after graduation to do some work with the car and license plate detection and accident detection on the roads. But actually, finally, I found out that my first company, Abi Production, has opened the Advanced Research and Development Department, where the work is similar to what I've done in academia. So I'm actually joining them next Monday. So in industry, actually, you have an opportunity to choose what you want to do, even if you need to switch the company. So there is a bit more flexibility than in academia. In academia, you join the university and you need to graduate, I don't know, 4 or 5 years. If you're doing master's degree, it's in 2 years. But in industry, you have more freedom, I guess. But you get more stressed also because always there is an opportunity to do some new project and you need to decide if you want to do that project, you need to switch the company. In academia, if you want to do some project, you can go to your advisor and tell that I strongly believe I can do some research in this field, and in most cases, your professor, your advisor will agree with you and give you an opportunity to do any project you like within your area of interest of your laboratory. So during my study at university, I was mostly publishing papers, doing research work and publishing papers, and our laboratory was focusing on the conferences. You can see I had, I think, 41 conference publications during my combined course of master's and PhD, and only 3 journal publications, and one of them was as the first author, but it was the top 10 actually journals in our field is IEEE Transactions Industrial Informatics, so I'm a bit proud of it. And mostly I was focusing on IEEE conferences and workshops. IEEE is a huge society of industrial engineers where we share our knowledge at conferences and workshops. And now this society actually provides some opportunities to actually find a job or to kickstart your startup. And my research was focused mostly on smoke, fire, and road lanes detection. But actually, we had so many projects in laboratory, so I participated in them even sometimes partially. I wrote some part of code for one colleague, some part of code for another colleague. So actually, I participated in many projects. And it is a good thing while you're studying, when you're doing your master's or PhD, you have so many fields where you can apply your knowledge and you can try yourself. If you want to do this or that project, maybe you're fond of hardware or you're fond of software, you can try really many things. When you get a job, actually your employer tells you what to do, and you don't have so much flexibility as you had in academia. So I really missed that flexibility when I was working at Abi. So probably I'll have it again, I hope, at Abi, is at the new department. So I started my research work as a classic computer vision researcher, image processing computer vision researcher, I tried to devise some algorithms to detect smoke. We participated in the autonomous car competition held by Hyundai company and Kia. And Dr. Joko was also in our team where we tried to make our car move autonomously. And my task was to detect smoke in front of car using camera and LiDAR. And Professor Joko's part was to detect people in front of the car. So we combined all our knowledge, all our codes into one big project. And our car actually moved in the competition. We didn't win, but it was a really nice experience. And then I found out that the algorithms I created, they work well in the exactly that hardware polygon where our car moved. But when I tried to apply smoke detection to surveillance systems, it just failed. So I decided I'm going to do some classic machine learning. At that time, it was 2014, I guess. So I applied ADA Boost and SVM and tried to create my own features as a researcher. I didn't actually create new classification algorithm. I just tried to create new features. And actually it worked, but again, it works under some restrictions. So I switched to deep learning and I graduated as deep learning researcher/engineer because many of our projects, so they were engineer projects, not research projects. And then I joined AB company already as a deep learning software engineer. So this is just a small example of the work done. It was smoke and fire detection. It was a part of project of intelligent surveillance system, and everything had to work in real time on i5 CPU. Also, after I switched to the deep learning part, in academia, I had really much time for experiments. This is the benefit of being in academia. You have time. You can do projects as you like. No one tells you how to do research, how to achieve something. You have just a general goal. You need to create the algorithm which works better than state of the art. That's all. And you can try different approaches. When the deep learning became popular and powerful in 2015, 16, after it won in every ImageNet competition, I tried to use deep learning for my smoke detection. So I combined CNN part, convolutional neural network part. I fed some frames to the CNN, and then I created a vector from that frames, and then gated recurrent units, which are RNN. They predicted if in this series of frames I have the smoke. So combining my classical computer vision and classic machine learning and deep learning knowledge, I went to the industry. And actually, you can apply that knowledge in the industry as well. What you're doing in academia, you actually can apply in the industry, and you don't lose your time doing research, because in the industry, you also need to solve difficult problems, but these problems are a bit different than in the academia. So what are features of academia? Your focus is usually the publication. So you need to apply for grants to get money for the hardware, but when you're conducting your research, you are self-directed. That means you choose the way how you want to solve the problem, and the means whether you want to use machine learning or classic approaches. Deep learning is a part of machine learning. And if you publish papers, you're a good researcher. If you don't publish papers, even if you created something really nice, some exciting algorithm, you don't publish, you don't push the science forward. That means you do nothing. But in industry, it's vice versa, you can say. You create some product, you do some research, actually, you try to devise new ways to solve the problem, But if you publish too soon, your company loses competition to other companies because they can re-implement your algorithm. So there is a problem when if you really like to do research and you like to push the science forward, make the world better, it's a bit more difficult in industry. Yes, sometimes you can publish, but you need to wait a bit so your company can conquer the market. And there is in academia, there is a really nice thing is collaboration. You collaborate with your lab mates when you're solving the problem. You have regular meetings where everyone discusses how to solve the problem. Also, you join conferences, workshops, where you speak to people who really want to share their knowledge. While in the industry, when you speak to workers of other companies, they don't really like to share their knowledge because their companies want to earn more money and they don't want to give you this opportunity to use their algorithms. And also, you have really long development time. There is no actual strict deadlines in academia. Yes, there are deadlines like you need to graduate. So for master's course in 2 years, you need to publish a journal paper, for example, or a couple conference papers, and you have deadlines for conferences. But if you miss that conference, it's not a big problem. You can publish maybe at the next workshop on conference, maybe 2 months later. And you have maybe even like a year for the whole project. In the industry, the time slots are very, very short because you need to push the product to the market and you don't have time to experiment, to try all the ways you'd like. So this is a big benefit of academia. If you have the bright minds and you have your ideas, you have time to try all of them. So this is just one small example of what you're doing in academia. You have some algorithm, you're creating your algorithm, your experiment, you mix some steps, and what you can do, you can try different, not only software, but hardware. You try, what if I use GPU to speed up the processing and actually find out that some parts work faster with GPU, some parts actually slower, they work slower on GPU because of memory bottlenecks. And you can try different classifiers, try many features. You have time to create your own features. And then when you created like 100 of them, you already forgot what are they. So you apply principal component analysis to remove the ones which do almost the same thing, which correlates too much. So you have time for experiments. In industry, you need to have the need to be done way of thinking. You have a goal and you have a strict deadlines. So, for example, in 2 months, you need to create an algorithm which detects text on documents, and you don't have much time for experiments. What you do, you try to find the state-of-the-art papers and try to implement them directly. Your goal is not to push the science forward. Your goal is to push the product to the market. So you have a project-oriented research, and but a good thing, you have a direct impact. You did some research work, you implemented your algorithm, you convert it to the production source code and binaries, and when you have the direct impact, you see the results in a couple months. In academia, if you created some algorithm, maybe for the next 5 years, it will not be actually implemented in industry because of hardware restrictions. But in industry, you already take into account the hardware restrictions, so you make sure that your algorithm works in real time, for example. So you can see right now what you're doing, and you get satisfaction from that. And your algorithm should be fast and reliable. You don't care so much about the highest accuracy. In industry, we always try to beat the highest accuracy of the state of the art. We want to reach like just 1% of quality, so we are the best. In the industry, you don't have to be the best in the accuracy, but you need to be the best in how fast you create your algorithm and how fast your algorithm works and how it is reliable. And I'll talk a bit about reality in academia in South Korea, where I was studying with Dr. Joko. So while I was in academia, actually many projects were taken by our advisor to get funds, not to push the science forward. That means that projects were more like industry projects. So academia actually working in the laboratory as a research assistant prepares you to go to the industry because you need to finish projects which have strict deadlines, which have goals, and sometimes you're really limited by what you can do. For example, in experiments, or you're limited by hardware. So you're teaching yourself what you'll be doing in the industry. And we had some strong collaboration with industry, with our intelligence surveillance government project, where we had exact hardware and exact deadlines, which we had to follow. And actually, that project taught me how to work with a group of people, with my colleagues, and I was a manager of that project. So you find out how it is difficult actually to collaborate with other companies because they try to do nothing and get more money. And you need to persuade all of them to do their part of work. And also, we got a project from a factory near Seoul, near the capital. They were creating the autonomous car, which had to navigate along the magnets. So I programmed the STM32, like ARM processor, which can read data from the magnetic array sensors and communicate with the car using CAN protocol. So also, it's purely industrial thing. There is no research, but you get funds for your laboratory. So laboratory can buy computers and softwares for research work. I also created the sensors network to survey the air condition. It was a purely government project for 1 year. It was partially a research work. I tried to figure out the best way of communication with the Zigbee network, but mostly it was industrial work. So while you're doing, I'm talking about my PhD mostly course. I had combined master's and PhD course. When you're doing this course, you actually try to push the science forward, and also you get experience from in the industry from the project. Which your laboratory has to take to get more funds. So in general, what we do in academia and industry, to summarize, in academia, in my example, I read the state-of-the-art papers and I tried to figure out my own way of improving the results to get better quality. In industry, I try to read also the state-of-the-art papers and try to implement them directly to get results right now. I didn't really have time to do much experimentation to try really many things. I tried to make work the existing algorithms. Maybe if they didn't work well for me, I optimized them. I didn't create the really brand new algorithms, brand new neural networks, for example, because we don't have time for that. We need to compete with other companies to get more customers. So industry is not bad. It's just different from academia, and you have benefits in both directions of your career. So this is an example in the industry. When I joined the Abby company in Moscow, I had to detect text in the wild and do it fast. Company before me, they were detecting text on documents with very simple background, but now we were moving to the mobile phones era. So we wanted to detect text everywhere. You can see here's the example of my algorithm. It detected text in most cases, but we have here Zanzibar cafe. I still fail to detect text there, but it is actually okay. For the science, you want to detect text everywhere with all the conditions, any conditions, but In that case, if you're using neural networks, your neural network became so big, so large, it cannot actually be run on mobile phone, for example. So here, right now, from the very beginning, when I joined Abi company, I met the restriction that your algorithm should be fast. We really care about quality. We want to detect text, but if pushing like 0.5% quality forward slows down the algorithm by 2 or 3 times, it is not appropriate. So there is a limit how good your algorithm can be, and this limit is given by the hardware restrictions. So how I solve that problem? So the biggest problem in text detection using neural networks is that text is really elongated. I implemented the actually segmentation network, we can say, and the output neuron of the segmentation network, its receptive field couldn't cover the whole word. So we cannot actually tell that by just segmentation network if we have this whole word as the same word or they are different words separated. We could use some text detector like not text object detection algorithms like YOLO, for example, but YOLO was not created for so elongated objects. So we had to find this solution. How to do that to detect this elongated text, even when single word can be so long. And also in text detection, there is a problem that you can have words with different font sizes, and you need to detect them all together. So you cannot actually create your algorithm to detect text using the same font size. And actually, state-of-the-art approaches, they solved that problem, but they were so slow, we couldn't apply any of them to our neural network framework, which ran on mobile phones. So what to do? What did I do, actually? I found a solution which already solved that two problems with long texts and different sizes of fonts, and optimize it so it can work on mobile phones, even if detection quality dropped. And for industry, dropping in the detection quality is not so harsh as in academia. In academia, you always want to improve the detection quality. In the industry, you need to make it work because it's better to have a working solution with lower recall or precision than a perfect solution which doesn't work on your devices. So you cannot sell it. So how did I do that? I found the papers which show the problem of detecting long texts. One of the main paper I based my solution on, it was SIGLink. It's segments and links. So we have some text, and actually each pixel in the output network in different scales, it says, we can see green boxes, that I am a part of the text. And I'm thinking that geometry of the text is like that, of this letter or this group of letters. So every pixel votes that I'm a part of text, and I think geometry is like that. And also every pixel, we can see here, for example, votes if my neighbor to the right, to the left, bottom, or top is also a part of the same word. So by these votes, we can create links between pixels in the output of our network. And when we combine these links, we create the bounding box for the whole word. So in this case, we can solve the problem of limited reception field. And also when text has many scales, actually pixels vote in many scales. And then from one scale to another, there is a link which is predicted by the network, which says, okay, I can see a really big letter, but I also think that in the smaller scale, pixels also belong to the text. So you don't lose text in with different fonts, and you don't lose very long words. What I did also so here we found the solution to detect text, but the existing networks so slow. They're almost all based on like ResNet 152, VGG. What I did, I found out that time MobileNet version 2 was pretty fast from mobile phones. So I switched VGG backbone with MobileNet version 2, and it actually made the algorithm work really fast. And also, but it was not enough for us, so I made it even thinner. I removed feature maps from the layers and reduced the number of scales in which we want to detect text, like how different font size can be. So I've end up with this kind of architecture. We have some image and we apply 2D convolution, and actually we then apply depth-wise convolutions in all the next stages, because depth-wise convolution gives us the same result, but it requires fewer parameters, so it can be computed faster. You always try to get faster in industry. In academia, you want to get better in quality. In industry, you want to get faster by preserving the quality as much as you can. So the my network had just 780,000 parameters for the whole network. Sorry, there is a mistype. Like VGG has 90 million, as far as I remember, parameters. Here we have 0.8 million. So it's a huge improvement. And again, in the industry, speed is almost always more important than quality. Quality needs to be high enough, but without speed, you cannot implement your algorithm anywhere. So I called my algorithm is fast text, like fast text detector. And actually in F measure, I could beat the baseline, the SegLink, but there are algorithms which have really high F measure, but they work so slow they cannot be really applied in the industry. So they are purely research papers, which and authors of that papers, they didn't really care about processing time. In industry, you always care about that. So it was just a small showcase how the work is done in the industry. And to conclude, I want to say that work in academia is really satisfying because you push forward the science, you feel how you make the world better by that. So, and you really enjoy sharing your experience with others during conferences. I visited really many conferences, and every time there was a discussion and people really wanted to know what you actually did, and it is really satisfying. But in industry, it is satisfying to do work because you see the real application of your work, even if you cannot publish that work actually. So there are two ways of being satisfied. Sharing your work or seeing how your research work was converted to the engineering implementation and used by the real customers. So both ways are actually important for the development of our world. Pure theory doesn't move forward the quality of life of us, of the people, and pure application cannot actually move forward without the theory, which is created by research scientists. So industry cannot work without scientists, otherwise we would stay at the same technological level. And there is a small postscriptum. Abby recently started the Advanced Research and Development Department. So I'm moving back to academia style work with publications, tons of experiments, and hopefully brand new approaches. Because for myself, I really enjoyed the academia way of life, where you're always excited about what's happening in the world. You want to participate in many conferences, many discussions, and you are actually free to discuss what you are doing. So the company Abby, they figured out that doing research by themselves and not sharing knowledge is not the best way even for them. They cannot push forward their own products with just engineering work and the combination of state-of-the-art papers. They actually need to do their own research work to be the number one in the world. That means even industry now understands that academia or this research work done in the same style as in academia is so important, so it cannot be ignored. Thank you very much. This is all for my presentation, and I'm waiting for your questions.
Okay, Thank you, Sasa, for your presentations. Maybe before question and answer, I will try to make some kind of summary. So, so the audience will be more deeply to explore the question. Okay, from the presentations, Sasa has explained what is the difference between research in academia and industry. From this presentation, actually, uh, there are four key of differences between the academia and industry. First, if we take the research in the academia, actually we try to implement our ideality or what will we reach from the study. This is the first. But in industry, we need also thinking about how our product will be met with way of thinking. This is sometimes we cannot match with these situations. I mean, when we are research, actually we are working. Our idea cannot that's why when we are research in academia, we should set so we can more understand how people thinking about this product, for example here. And the second, again in academia, actually we are working in the long development time. It means because we are studying not only 1 or 2 years, sometimes we need to make our performance continuously improvement from years to years. That's why we are thinking about my research should develop by myself and how we can creatively to make many our research will be useful. But in industry, we are changed the mindset that if we are working in industry, we also need to thinking about deadlines, strict deadline. I mean, if we develop the product, we also thinking how long we can product this, how long we can develop this product, and the product will be used in the public mass or something. And the third, I also note from Sasa presentations is about the product itself. Actually, in academia, we have many, for example, many ideas related to the product. For example, we want to make an autonomous car, but if we're thinking about academia, we also thinking which research will relate it with our work. Then we try to make some improvement from others' work. But in industry, we also thinking about product-oriented research. It means we need research something according to the product what we want to improve. For example, here, and the last, and this is very. I think this is very useful for us. We need to think if we research in academia, usually we are make something better. For example, the performance of text detection is better, it's enough, or maybe more faster, it's also enough. But in industry, we need to make them fast and reliable is combined together, and this is the objective why we need to research in industry. Okay, for this session, maybe actually I have shared in the chat room. If you have some question or comment. Oh, this is Sasa. If you If you read in the comment, maybe I read the question, Sasa.
Maybe I
Basically,
can
actually,
read.
I have a little question here. How I can to get working at academia in industry, and it is possible if we take jobs when we in studying. This is maybe your experience, Sasa.
Okay, I'll start with the second question. Where is that? Share screen, presentation, share. So actually, when I was studying, even at my engineer's course, I was working at Vion company as a software engineer. But actually, I was a working student. So you actually, yes, you can find a job when you're a student, and this is a really good way to improve your skills, because sometimes when you're studying, you take many classes, you're studying some theory and you do some exercises, you don't actually get the grasp of how they're actually applied in the industry, all these algorithms. And without real application, without real practice, you tend to forget everything you studied. At least in my case, when I studied theory and I couldn't find out where I can apply it, I forgot all the equations and forgot how to do that. But if I could find a job, even like which doesn't pay much, but I get experience from that job. I actually remembered this thing, and then maybe 10 years later, I can tell, yes, there was some algorithm which works well for this case. Even if I forgot some equations, I can Google them, but I know how. Without the real practice, you even forget like what kind of algorithms there exist. And during it was my undergraduate course. In the graduate course, master's and PhD, actually I was also taking projects to solve the real life problems, but it really depends on your university if you can get a job. Companies, they really like students and they offer the internship positions. Sometimes they are paid, sometimes not. But mostly companies, they like to invite students to give them some experience and to make students love their company, so they actually join this company after they graduate. You need to search Indonesia. I don't know. There is a special position, for example, in Germany. It's called work student, or working student, and many companies offer that kind of work. The second question was, is it possible to find work at the academia in how I can to get working at academia in industry. Many companies right now, they open their research and development departments, and you actually can have experience similar to academia in industry. For example, now I told you Abi, they found out they want this academia-like experience in their company, and they actually opened the department at university in Russia. So they're teaching students by themselves, and they're having their research laboratory at university. So students, while doing their research work, sometimes they can give insights to company and they can provide some new algorithms. It is not guaranteed, but sometimes in 3 or 4 years of work, a PhD student can give a brilliant idea, and this idea is shared for the company. And also, many companies like Tesla, Microsoft, they have research departments where you can actually do research. You read papers, you try really many algorithms by yourself, you combine them, you try to create something new, and they allow you to do that because they have now enough money to do research work, and they understand that even if you don't give results like in even 6 months, but if you do some nice research in 1 year, they can be like #1 company in the world in their field if they allow you to do your research work. So there are many companies now which have research and development departments. you can pursue them. You can apply to that companies. And actually, I have a good experience with being interviewed by that companies when I was looking for a job. And many of them, they really care about what you know in machine learning, in programming, in deep learning. They try to dig really deeply if you understand the mathematics, the essential parts of machine learning, so you can create your own algorithms. Not just implement existing ones, but creating new algorithms is also important now for companies. So next question.
Okay.
Maybe I can read also.
Sasa, I think the third question is very interesting from the director.
Okay.
Mr. Professor Termudi.
When the products of research have not been published for commercial purposes, to the market, sometimes industry doesn't want to accept his prototype product. How to convince industry or company regarding new findings from academic sites? I think when industry doesn't want to apply the new findings or the new, even if research has created the new project, the new hardware, they don't want to apply. It is a really good thing to catch the researchers from the companies at conferences and workshops and talk directly to them. I believe that because companies still, they send their researchers to the conferences to find out what's going on in the world. And sometimes CTO of the company, through who you actually want to communicate with the company, CTO may not understand benefits from the recent research. Maybe they graduated like 20, 30 years ago and never did research because they're chief technical officers. But the researchers who work in the laboratories or research departments in the companies, they always try to dig what's going on in the world. And sometimes they may miss your advancement, your publication, because right now there's like hundreds of publications, I guess, every day on archive.org website. It's easy to miss something, but when you meet someone in person at the conference and workshop and you have personal discussion, I think there is a good chance that your idea or product will be taken by the company if you can persuade the person that this is a good thing, a good product or good research result. I think personal communication is very important because in the internet it's very easy to miss something good because there's so much information the person cannot process it well right now.
Thank you very much, Mr. Speaker. Yeah.
Thank you for your question.
Alexander.
We still have 3 questions, Sasa. Maybe this is fast. First is about the second question about funding and grant. How, especially for the young researchers, it is sometimes difficult to get the funding or grants. And the second is about AI, artificial intelligence. Is it possible AI to implement in the education or in the academia? And the third is from the latest question is about postdoc. PhD is it useful to doing postdoc? So short 3 questions,
Okay.
maybe 5 minutes enough. Okay.
Okay, let's try to answer the last actually I see right now. It's a postdoc. Postdoctoral experience is less important than real work experience if you want to get some good position in industry. When you're a postdoc, you still are doing research work and you don't get skills essential for the industry. You have some grant for 1 or 2 years, and you need to finish one project, and you don't have these kind of restrictions which you have in industry, like processing time and reliability of your like algorithm, or I don't stability of your machine learning algorithm, like stability of with outliers, and also in the industry, when you're doing research work, you created your really nice algorithm, and then you need to implement it using C++ language, for example. So it is not only good algorithm, but also you need to have skills of good implementations, bug-free implementations, and you need to have experience in the agile environment, agile approaches like Scrum, where you have continuous integration, continuous development style of working. Every week, maybe your goal actually is changed a little bit. So the ways, even how you implement your work, how you do your work is different in industry from academia. So when you're doing your postdoc, you don't get that experience, and you need to start from scratch after your contract is finished, like in 1, 2, 3 years. However, is there any ICT field that can be as good as an AI field that can be used either by academia or today's industry? AI is not actually everything right now. AI is a good thing, but there are many applications or fields where you cannot apply AI right now. If you're strong in mathematics and creating your own algorithms, you can go to the autonomous vehicles. Recently, I had a talk with my friend from Germany. He's working in the Continental company. They're creating algorithms for autonomous vehicles, and processors, small computers in the cars actually are not so fast, so you cannot apply any machine learning there. You need to create really nice algorithm by hands. You need to create all the features and decision rules by yourself, so they can be fast, reliable, and can be programmed into ARM processors without any GPU. So yes, you can apply, you can do research work even without AI. But right now, AI is so popular, it's just easier to get job when you do AI. I hope I answered your question. I understood correctly. Also, the last one is a young researcher who just get into research, especially in academia. We might face some problems such as in funding and showing your profile as a researcher. When you just start your research career, you have to open your ResearchGate account and also LinkedIn account. Now it's difficult to reach some people directly in person, and your research is known by your LinkedIn and ResearchGate and some Google Scholar account. Otherwise, there are so many people you don't get known by others. So now you need to promote yourself through the internet. Personal connections are really important also. Every time when I went to a conference, I met interesting researchers and actually heads of some branches of IEEE society. When we met in person, they offered me, oh, maybe you want to go to my country to work there because I see you have a bright mind, or you want to join this group which decides the new standard. Sometimes you can get known by others in personal meetings, but the faster way, I guess, is to reach people even through LinkedIn. Just write them messages, and tell them about your research, and maybe they get interested in you, and you can get really nice network of people who you talk with, and finally they can offer you some interesting position or project. Right, I have many friends at LinkedIn right now, and almost every day I get emails. Do you want to participate in that project? And do you want to join our company? Let's have a talk. You need to spread knowledge about yourself by contacting many people. And also about funding. in my experience, I didn't have to find money for the projects. It was done by our advisor, Professor Joe, but it was really hard work. He wrote grant proposals, I guess, every day. He submitted everywhere because right now the world has fewer money, less and less money. Sorry. So it's difficult to get funds right now. So probably when you write grant proposals, you try to reach not only your government or your university, but there are some big, not laboratories, big groups like DARPA. If you create some really exciting robotics example, like your robots, you can apply for DARPA funding, but usually the only way to just write really many proposals to the government and also to private companies. We had experience in our laboratory in Korea where our professor got actually funding from the private companies which needed the work to be done, but they didn't have their own research departments. So you can be like outsource maybe research department for some company, or even outsource research employee, a singular person, if you can solve the problem by yourself. Just propose to everyone you find, to every company you find, maybe on the internet or in person. I think that's all. I don't have knowledge about everything, especially about funds. I just told you about what I saw our professor did, and he actually successfully could get money for our laboratory. So he applied to everyone he could find, to every company.
Thank you very much.
Thank you, sir.
Okay, I hope 5 questions is satisfied with the explanation from the Alexander. Of course, the session only 1 hour. That's why I think it will be not enough for every question from the audience. But from this, we try to make some kind of summary. Maybe 1 minute, Sasa, you can summarize what is difference academia and industry, and how we can smoothly move from the academia to industry. 5 minutes.
Okay.
Thank you.
Okay, thank you very much, all of you, for joining this session, this webinar. So the difference between academia and industry is not so strict or not seeable. The transition can be done smoothly if you do research work, and also you try to get projects which solve the real life problems right here, right now. So you get experience needed in the industry when you actually not only create algorithm, but implement it in C++ or using CUDA to make it work fast. This is how I did. I used CUDA and C++. And then when I moved to a company, actually I had many essential skills, not all of them, but many of them to get a job. So do research, but also try to find out how to make your algorithms, your approaches work not only with high quality, but also fast. All the industry, they need fast and reliable things. With good quality, but fast and reliable. If you take care about fast and reliable approach, I think you already get a good way of thinking needed in the industry. Yeah, be fast and reliable. That's all I think. The only difference, actually.
Thank you very much, Sasa, for your time and all the knowledge and experience. I think this is very useful and valuable for us, for students, for lectures, and also maybe for researchers. Professor Turmudi will give something.
Okay, then. Thank you very much for giving us some knowledge and experience from Mr. Alexander. Yeah, I think it's a good thing for us as novice. I think, yeah, because we are still young. Undergraduate for year 3 is still need to learn more about the relationship between academic side in our university and the industrial side in the company. Yeah. Therefore, your information will be valuable for our student and some colleagues in our university, especially in UPI Purwakarta. Thank you very much.
Thank you.
Pak Joko, please.
Yep, Prof. Baik, Prof. Ya, baik. Okay, our session is will be finished. I hope all the audience will get benefit from this webinar. So the first thing for my students in the research methodology, we need to think why we need to be a researchers. That, as Mr. Sasa explained, that researchers is one of options. You can also choose like engineer or something that's useful for your knowledge. But to be researchers is a very concentration is one of the key how we can success in research. Of course, research industry or research when we are in academia. Thank you very much, Alexander FIlonenko, Doctor of Philosophy, and also Professor Turmudi, and all the civitas academica for UPI. And we also wish Mr. Alexander will be more successful in his company. And I also asked him, Professor Turmudi, as Mr. Supri asked to me, is it possible to collaborate from UPI and cooperation between UPI and Mr. Alexander company? And so this is open. I mean, is it open to make collaboration between UPI and research development AB? That's why after this webinar, I will continue our communication with Mr. Alexander, and we try to grab what kind of cooperation that's benefit to face from AB and also the UPI. Thank you very much for all the audience for your time and attention. If you have such as question or suggestion for this webinar, don't hesitate to contact the committee of this special lecture. And also don't forget we also have a certificate for the participants, and also we will share the slide presentation to all the participants. Thank you very much. We hope we can meet in the near future in the other special lecture. Thank you, and we finish the meeting and we close. Thank you, Sasa. And
Thank you very much.
Have a great day. Thank you for joining this webinar. Thank you for
Sasa.
inviting me.
Okay,
Goodbye.
Goodbye.
Pak Joko kalau bisa segera ditindaklanjuti ini ya. Bagus sekali
Baik, Pak Direktur.
kerjasama dengan sana ya, sehingga kawan-kawan memiliki ini akses ya.
Baik,
Kan.
baik Pak Direktur. Baik, nanti akan kami
Terima kasih
tindak
Pak
lanjuti.
Joko, terima kasih sekali nih.
Terima kasih.
Terima kasih Pak.
Sama-sama. Monggo.
Tutup ya Mas Jiman ya. Terima kasih Mas Jiman.
Siap Pak. Baik, terima kasih kepada Mr. Alex and Dr. Joko Haryono yang telah memandu ya dalam acara webinar ini. Selanjutnya apa ini Kak Anissa?
Nah, kita sekarang sudah ada di sesi akhir ya, luar biasa sekali pemateriannya teman-teman, semoga bermanfaat untuk teman-teman semua. Mungkin di sini ada kali ya satu orang yang ingin menyampaikan kesimpulan atau apa sih yang ditangkap dalam webinar kali ini? Ada nggak nih?
Bagusnya ada refleksi ya.
Ya, betul Pak.
Ya,
Gimana teman-teman, ada yang ingin memberikan sebuah kesimpulan dari webinar kali ini?
Misalkan masih susah bahasa Inggrisnya gitu ya.
Iya, betul.
ya benar Kak.
Masih perlu apa yang perlu ditingkatkan gitu, sehingga nanti di kelompok-kelompok kemahasiswaan itu perlu improve your English gitu ya. Sehingga apa yang disampaikan oleh pemateri dari luar kita bisa memahami.
Betul Prof. Mungkin saya coba memberi ini kebetulan karena mata kuliah kami
Ya.
metodologi penelitian. Jadi memang yang pertama yang saya rasa sebagai sebuah kehilangan besar ketika saya dan juga Alexander keluar, artinya lulus dari perguruan tinggi kita itu, kita memang selama kita belajar di Korea Selatan itu kita diberikan wadah yang sangat istilahnya sangat kompetitif. Seperti yang dikatakan Alexander tadi, selama studi kita selalu dipantau oleh supervisor profesor kita. Kita juga punya research group. Research group ini tidak hanya intensif bertemu secara artinya secara online atau meeting semua, tapi kita juga diberikan beban tugas yang itu memang harus kita presentasikan setiap minggu. Dan ini seolah-olah yang disampaikan oleh Alexander tadi, bahwa kita memang dengan diberikan wahana yang sangat baik tadi, memang akhirnya bisa dibilang lab kami ini termasuk lab yang more internationally dibanding lab-lab lain. Karena di lab kita itu bisa dibilang jumlah mahasiswa internasional itu bisa dibilang terbesar di kampus kami. Kalau negara lain mungkin ya artinya jumlah mahasiswanya hanya di lab lain mungkin hanya terhitung di bawah 10. Kita itu pernah sampai 25 mahasiswa, dan itu very internasional, artinya dari berbagai negara. Dan dari situ baru kita merasa bahwa kita itu benar-benar digembleng habis-habisan oleh profesor kita. Untuk kita itu meskipun dari bendera negara yang berbeda-beda, tapi sebetulnya kita bekerja untuk hal yang sama, yaitu di ilmu pengetahuan. Di situ kita dapat bahasa Inggrisnya tergembleng, terus pengetahuan kita juga tergembleng, bahkan background pendidikan sebelum kita ke situ pun kita akan banyak istilahnya banyak diberikan semacam ini. Dan sebetulnya kita tuh paham nggak masalah ini? Artinya kita sudah S1, S2 bukan artinya gelar itu menunjukkan pengetahuan kita, tapi ternyata di balik gelar itu bagaimana pendidikan kita itu membuat pengetahuan itu menjadi bagian dari diri kita. Bukan kita belajar itu bukan untuk hanya sekedar tahu, tapi bagaimana kita mengimplementasikan. Nah, ini sehingga memang saya rasa memang Sasa dan saya juga sangat merasakan. Memang lulusnya lama. Di lab kita itu tidak ada PhD yang bisa lulus 25 tahun. Jarang sekali. Bahkan Alexander itu karena beliau master dan PhD lanjut itu 7 tahun lebih. Jadi memang benar-benar exciting lah pendidikan selama kami di lab. Dan teman-teman kita meskipun sudah lulus sekarang kita masih komunikasi karena profesor kita masih membuatkan grup. Grup itu kalau profesor punya macam event atau dia ingin berencana membuat semacam kegiatan kunjungan ke negara, nanti alumninya dikumpulkan di situ. Mudah-mudahan ini di UPI nanti bisa dirintis nih, Prof.
Ya.
Iya.
Oke, satu. Ya, terima kasih ya Pak Joko ini memberi.
Dan itu tidak hanya S3 loh, Prof.
Betul.
S3 S2 kita pun itu mahasiswi mereka sudah punya semacam transfer knowledge lah dari seniornya. Seperti itu.
Baik, ini saya kira sangat bagus sekali Pak Joko ketika Bapak mengenalkan para mahasiswa untuk dapat link ya. Sehingga nanti teman-teman yang masih S1 ini kalau punya niat yang kuat untuk bisa S2 itu sangat dinanti sih sebenarnya di Korea gitu. Apakah ini untuk riset asisten atau memang nantinya untuk itu ya ngambil S2-nya sekalian. Memang yang namanya pengambilan S2 di luar negeri itu kan sebenarnya kerja di perusahaan ya, di industri, nanti pengalamannya ditulis dan tulisannya menjadi tesis begitu. Itu umumnya seperti itu kalau studi di luar negeri ya, di Jerman, di Belanda juga sama begitu. Termasuk di Australia begitu, apalagi di Korea ya, di dunia industri ini begitu. Makanya teman-teman jangan patah semangat ini, silahkan bekerja keras ya untuk bisa meraih capaian-capaian yang bisa berguna untuk negara dan bangsa tentunya begitu. Terima kasih Pak Joko.
Baik, terima kasih Prof. Turmidi, MED, BSc, PhD yang telah sharing ya Pak. Nah, selanjutnya, dari teman-teman ada yang ingin disampaikan. Bagaimana Kak Anissa?
Ya, mungkin dari teman-teman di sini ada yang ingin menyampaikan kesan dan pesannya mengikuti webinar ini.
Boleh mungkin dari mahasiswa yang ambil mata kuliah Medlib.
Mungkin ditunjuk aja kali, Bim.
Oke, siap Kak Anissa. Baik ya, mungkin dari Teh Asri. Boleh Teh Asri? Halo Teh Asri. Halo Teh.
Teh Sri masih bergabung?
Halo Teh Asri. Sepertinya tidak ada Kak Anissa.
Bergeser satu.
Siap. Baik, dari Kang Aldi. Dari Kang Aldi, mangga. Halo Kang Aldi.
Ya, hadir. Ada
Siap.
suaranya nggak?
Ada Kang.
Ya, sebelumnya terima kasih nih Mas. Terima kasih kepada Pak Joko yang telah menghadirkan pemateri yang sangat luar biasa gitu dari Moskow ya teman-teman ya. Iya, dari Moskow.
Ya benar.
Ya, meskipun apa ya? Mungkin kesannya ya mungkin karena apa ya? English Aldi agak kurang gitu. Jadi agak sedikit terhambat dalam segi memahami gitu. Tapi sedikit demi sedikit lah untuk belajar dan juga alhamdulillahnya berkat adanya ini gitu minat untuk apa ya jenjang S2 dan ke luar negeri itu bertambah gitu sedikit demi sedikit gitu. Yang tadinya itu agak dulu waktu semester 1 punya banget harapan buat ambis banget lah gitu, pengen S2 ke luar negeri gitu, tapi semester demi semester yang telah dilalui merasa insecure banget gitu, merasa apa ya, menurunkan tingkat targetnya gitu, jangan ke luar negeri gitu, cukup S2 di Indonesia aja gitu. Tapi dengan adanya Pak Alexander tadi, ya sedikit memompa kepercayaan diri lah gitu, bahwa kita tuh jangan apa ya, jangan menurun, jangan patah semangat lah gitu. Kita harus bisa langsung ke luar negeri nanti gitu, dan bisa meneruskan cita-cita kita gitu. Mungkin gitu kan kesannya mah, kesan pesannya mah. Intinya mah
Baik,
semuanya mantap.
Baik, terima kasih Kang Aldi. Nah, selanjutnya nih ada dari Teh Monika Putri. Mangga dari Teh Monika.
Ya, oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Ya, perkenalkan nama saya Monika Putri dari kelas 3 CBGSD. Oke, kesan dan pesan selama mengikuti seminar ini, alhamdulillah senang sih. Cuman walaupun sedikit kurang paham gitu ya. Kurang paham sama materinya yang diomongin gitu. Tapi tadi berusaha banget untuk biar paham itu dengan translate lewat ayo dictionary gitu kan. Jadi ada beberapa yang paham gitu, tapi walaupun nggak paham keseluruhannya gitu. Nah, dari seminar ini juga menumbuhkan motivasi juga gitu ya. Kalau misalnya ternyata kuliah di luar negeri itu sangat sangat pokoknya itu sangat dinanti-nantikan gitu ya. Apalagi ilmunya itu juga bermanfaat yang pastinya belum tentu ada di Indonesia kayak gitu. Nah, setelah melihat dari Pak Profesor Alexander tadi juga semakin meningkatkan rasa keinginan untuk ke luar negeri gitu, untuk kuliah di luar negeri gitu. Karena ternyata emang di luar negeri itu kita mengemban ilmu di luar negeri itu nanti juga kalau kita balik ke Indonesia itu ilmunya bisa kita share juga ke negara Indonesia gitu. Jadi pokoknya memotivasi banget gitu. Jadi pengen belajar bahasa Inggris lebih kayak gitu sih. Oke, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih kepada Teh Monika Putri yang telah memberikan kesan-pesan. Nah, selanjutnya gimana Teh Anissa?
Nah, selanjutnya karena hari sudah semakin sore juga ya, alhamdulillah acara ini sudah berlangsung dan berjalan dengan baik dari awal hingga akhir acara sekarang. Mungkin kita tutup aja ya, Kang Dimas.
Siap, boleh Kak Anissa.
Baik, untuk informasi lebih lanjut terkait sertifikat dan PowerPoint yang tadi telah dipaparkan oleh pemateri, bisa kalian cek grupnya ya. Sudah ada yang share. Nah, maka dari itu saya Nisa Yasmin Ula dan juga rekan saya Dimas, mohon maaf apabila ada tindakan maupun ucapan yang kurang mengenakan. Kami tutup. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih semuanya.
Terima kasih.
Terima kasih.
Sampai.